That's me. Hello, Facebook. Welcome back to another session for MVP Days Live, coming to you from Vancouver, British Columbia. We are so pleased to have another amazing session for you by fellow MVP, Clint Wyckoff. He's going to be talking to you today about ReFS. And if you don't know what ReFS is, you need to watch this session because you will know everything
you need to know by the end of it.
Everything
Absolutely.
that you need to know about ReFS. So with that, I'm going to hand it over to colleague Clint here, and we have you live.
Awesome. So thanks, everybody here in Vancouver. We really appreciate you coming out. So this is the second day as part of the MVP Days Roadshow. On Monday, we were over in Edmonton. Obviously, today we're here with you folks in Vancouver. And then Friday, we're actually going to be in Calgary, which is actually where Dave is from, as well as one of my fellow colleagues, Michael White, on my team actually lives in Calgary as well. But so thanks for coming out, taking a few minutes with us. So the purpose of today's session is to give you all that you need to know about ReFS, Resilient File System, inside of Windows Server 2016, and why this specific file system should be something that you look at whenever you're designing your backup repositories. So my name is Clint Wyckoff. Quick show of hands for those in the audience. Does anybody out there today run Veeam inside of your infrastructure today?
We just bought it.
You just bought it.
We haven't deployed it yet.
Well, that's actually good for you to come to this session because you can hear about this and then you can take it back. And whenever you're implementing Veeam inside of your environment, you'll be able to do it in the best way. And then you run Veeam as well? Yeah? And everybody else in here will be running Veeam by the end of the session. But that's not the purpose of this. This is not a sales pitch. This is a technical discussion. So, quick agenda.
Hold on. Can I get a round of applause for that for everybody?
This is absolutely 100% not a sales pitch. This is not the purpose of it. So I've given this presentation in a couple of different variations. So it's evolved over the course of the last few months because we've learned a lot about infrastructures that are deploying ReFS, Resilient File System, and using it as backup repositories. So if you go out and do your Google foo, you'll find it's called a couple of different things, right? If you were to spell it all out, it's Resilient File System. You'll hear some people call it ReFS. You'll hear other people call it ReFS, right? So all of that means the same exact thing. And it's a really cool file system because it was originally introduced inside of Windows Server back in the 2012 version, ReFS 1.0. It had a lot of problems, right? There was a lot of issues and things like that that Microsoft has slowly but surely updated over the course of time. Windows Server 2012 R2 was version 2.0. Windows Server 2016, if you've done any playing with any of the technical previews, for instance, like TP2, TP3, it was ReFS 3.0 inside of TP5 and the RTM and the GA build of Windows Server 2016. It's actually ReFS version 3.1. So it's been updated. But some of the really cool parts of this is the fact that it is truly the operating or the file system of the future for Microsoft. Just like NTFS was back, in the mid-90s, whenever they were designing NTFS, they're like, this is the file system of the future. Everything that runs inside of Windows Server runs on NTFS, right? Anything new moving forward out with Windows Server 2016 and greater, they want you to deploy ReFS. Look at Hyper-V. Look at Storage Spaces Direct. Those are some of the, especially Storage Spaces Direct is one of the newest technologies in Windows Server 2016. The only way you can deploy it is on Resilient File System. That is the only way that it will be able to be deployed. So some of the improvements that have made, now it's a 64-bit operating system, meaning that you can actually have a single volume in the range of 16 exabytes in capacity, right? So it supports a lot more objects. It's a lot more resilient. We'll talk about that here in a few short minutes. But one of the kind of limitations of it is the fact that it does not natively support the Windows Server deduplication storage role. So one of the things that Microsoft added in 2012 R2 is the ability to do post-process dedupe on like a D drive or an E drive, for instance, right? We had a lot of customers, especially in Veeam, look at that for smaller amounts of data, right? Because it could dedupe files up to 1 terabyte in size. Windows Server 2016 actually changes that to 4 terabytes in size, kind of being the supported upper boundary. But if you're deploying ReFS as the file system, that dedupe rule is not able to be added to a ReFS volume. Another kind of limitation of it is the boot partition to C drive still has to be NTFS. It's not supported with ReFS. Small wish, as I mentioned, right? C drive, not supported. And then the last piece here being on the very bottom is the seamless integration with storage spaces and storage spaces direct. The resilient file system is the way that you have to deploy both of those storage spaces, traditional, or the new storage spaces direct. So it comes in a few different deployment models. The first one being kind of a simple volume. And this is where we see a lot of folks inside of the Veeam infrastructure taking advantage of ReFS. So if I have a Dell or an HP server, right, a JBOD that has just a bunch of disk, local disk attached to it, I install Windows Server 2016 on it, and then I create a D drive or an E drive, and I format that D or E drive with the ReFS file system and use that as a backup repository. That is actually a fantastic way of getting this up and running very, very quickly. It can be either on a physical bare metal piece of hardware, or it can be on a virtual machine. And all the testing that I've done has been on a virtual machine that I've just added another VMDK or VHDX to and format that with ReFS. And I have some really cool numbers to show you here at the end. The second deployment model is kind of the shared storage spaces and the storage spaces direct methodology. Both one of these creates an external software-defined SAN, right? But with that, I'm able to set up and have either a mirror copy, or I can either set up redundancy from a parity, okay? Each one of those has pros and cons that go with it. Kind of, if I'm setting up a mirror, right, what's the number one limitation of a mirror? Anybody? Size, capacity. If I have 1 terabyte worth of disk, I instantly chop that in half because I have to keep the other half to have the mirror copy, right? Parity, a little bit better, gives you more redundancy, but it's going to give you less performance, right? So you kind of have to weigh out pros and cons. The storage spaces direct, we do see customers that are looking at this, and Dave and Alan are actually doing a session at Veeam on using storage spaces direct as a Veeam repository, but it does require the data center edition of Windows Server. So if you're not a large enterprise or kind of have an ELA or an all-you-can-eat type of licensing model with Microsoft, there's a cost that's associated with the data center edition above standard. So why should anybody consider a new file system? Backup data is very, very important. It's something that you need to make sure is going to be around when things go bump in the night, right? If it hits the fan at 3 a.m., I need to make sure that my data is online and I can do my recoveries and restores as I need. So being kind of putting my admin hat back on again and think about Microsoft. You know, traditionally you don't think of them as a storage array provider, right? Like file systems, right? You don't generally associate those. Like you don't want to have a software RAID. Typically you use a hardware RAID device, right? That's one of the differentiators of storage spaces direct, for instance, is it doesn't require any sort of hardware RAID. It all leverages software under the covers to manage that mirror and parity. So why? This is the file system of the future. Hyper-V 2016, if you go out and have a premier field engineer come into your environment and say, hey, or a consultant like Dave or Alan come in and talk to you about Hyper-V, they're going to recommend you use ReFS. So the important part of that is that it has a huge backing from Microsoft. So if there are bugs, if there are problems, it's going to get fixed very, very, very quickly because they have so many customers that they're recommending to leverage this file system. So it has a huge development backing. Removing some of the nasty NTFS file system limitations being the last bullet item there, removing some of the check disk problems that have been present before with the 64 terabytes, right? Not being able to run check disk against the volume that is larger than 64 terabytes. And then the middle item here being able to support, as I mentioned, up to 16 petabytes worth of capacity, right? So this here is directly taken from MSDN. So if you go out there and do a quick Google search just on ReFS and go out to the MSDN article, this is exactly what you'll find. So you'll see here this is the preferred data volume of Windows Server 2016. The other kind of cool bullet items that directly, again, straight from Microsoft themselves here is the data integrity. So now ReFS has something that's called data integrity streams. So it'll automatically look for corrupt blocks of data and use that mirror copy or that parity bit that's present inside of the cluster to automatically try to heal those corrupt blocks. So you heard Dave a little bit earlier in the previous session talk about bit rot. So data that's present on a hard disk for an extra long period of time. So imagine a repository that I have 6 years, 7 years, 8 years worth of retention on there. Right now with these data integrity streams, I feel a little bit more confident in keeping that long-term data on this file system because it's going to notify you via the event viewer if there is a problem. Speed and efficiency is another extremely important characteristic because, as I mentioned, Hyper-V itself is taking advantage of some native APIs. Block Clone API, Instant Fixed Disk Creation are two of those that we'll talk about here in this session just in a few more minutes. So the use case that we as an availability provider being Veeam Software focus on, there's two different personas, right? There's a write persona and there is a read persona. Each one of those has cost associated with it, right? So, or a factor associated with it, meaning how fast can I back up, which is write, and how fast can I restore, which is read. So those are the two different kind of use cases. How fast can I back my data up, which is my recovery point objective, or how fast can I restore my data, which is my recovery time objective. So ReFS is really perfect for both of one of these scenarios. And the first one that we're going to talk about is write. So we actually did some tests with Iometer and a partner that we have in the ecosystem out there. So I have an ReFS formatted volume here, right? Each one of these pie graphs represents a test that was run. On the left-hand pie graph, I have an ReFS formatted volume without data integrity streams. This data integrity off means data integrity streams is disabled. And it is disabled by default, actually. So the test that we conducted was 4K random writes across this volume. And you can see here that, yes, a 4K test with data integrity streams off, every one of the blocks of data lands in 4K, right? That's what we would expect to see. Much like NTFS, whatever way the application is writing the data, that's the way that the file system is going to write it to disk. Whenever you enable data integrity streams, now my blocks of data are landing in much larger chunks. So you can see here 64K and larger, 4K some of them, 16K, 32K, 48K. So what the file system with data integrity streams enabled actually begins and functions like a log structured file system, meaning that it'll aggregate those smaller chunks, the 4K blocks together, and make larger sequential writes. So even though I've got 4K random, it'll actually write those 4K writes in much larger block chunk sizes. So that makes backup windows and backup performance a lot better for writing data. But now whenever I actually go to restore my data, it actually works very well too. So we perform the same exact test, 100% random reads off of that hard disk. With data integrity off, we can see the performance all over the map. It's so random, right? So with that, virtual machines, because if we think about the #1 use case of what ReFS is, and it is for Hyper-V VMs, that's kind of their #1 use case today. With data integrity streams on, the performance, and ignore this dip here, this is just an anomaly in the test. You can see that the performance is very predictable, right? It's consistent across the board. So this actually, I'm good. So this makes performance in activities like instant VM recovery, or instant VM recovery, if you're not using Veeam today, is actually powering on a virtual machine from my backup disk, right? So now if I have a virtual machine running off of my backup disk, like a production virtual machine would inside of a Hyper-V environment, it's going to be a lot better performance. It's going to be a lot more predictable for us. So some of the things that we've learned from customers, from partners, if you go through, and I'll show you guys what this actually looks like in the UI here in a second. If you actually go through Disk Manager, attach a volume, right? And I'm going through and formatting. I initialize it, right-click, new simple volume, next, next. NTFS is still the default. You have to change to ReFS. But the most important thing that I want to highlight here is changing the allocation size. So by default, it'll actually have 4K as the default cluster size. You want to change that to 64K, okay? And it's actually a blog here from Microsoft. So for larger data sets, whenever you're formatting an ReFS formatted volume, you have to use, they want you to use, you should use 64K cluster size for stability and reliability problems. They've had issues in the field with data.
So why not change the default?
So because it's only prevalent and apparent in larger data set sizes. So if I have smaller virtual machine hard disks on there, it's not as big of a problem. But if I have terabytes worth of terabytes in an individual backup file, that's where it starts to become more of a stability issue. And it's not, I haven't seen any issues with corruption. It's just been with blue screens of servers. So by enabling this 64K cluster size, this fixes these problems. But also, there's some caveats there. Since I'm writing my data in 64K cluster sizes, and the file system has to keep track of a lot larger metadata chunks, right? I lose 10% of my capacity. So if I have a 100 terabyte volume, I'm only going to get 90 terabytes usable whenever I format that with ReFS. And again, this is very current. This is as of January 13th. Microsoft came out with this little blog article, and you can get access to this afterwards, or you can just do a quick search there on the interwebs and find it. So here you can actually see inside the event viewer. So there's a nice little error code that comes up. Here's event ID 133. The file system detected a checksum error and was not able to correct it, right? In this case here, it was not able to correct it because there was no mirror copy or there was no parity, right? It was just a simple volume that we had deployed. So if I have tools like System Center Operations Manager or other monitoring tools that are reading off of event viewer data, I can get this information presented to like a NOC, for instance, or my Network Operations Center to get these alarms and have visibility to this. But I think the most important takeaway is understanding that the ReFS file system itself is aware of these issues under the covers. It's able to detect it, and it's making attempts to try to fix the problems for you on your behalf. So how to set and check. Because I mentioned that data integrity streams is not enabled by default. You have to go in and enable it manually. The nice part is whenever you add a volume to Veeam with ReFS, you don't have to worry about this. We take care of it for you behind the scenes. All right? You don't have to worry about any of this. But if you were deploying, say, for instance, virtual machines on here, you have to turn it on, right? And it's just, you can check the status, get file integrity, or you can enable, disable with set file integrity. And it's really easy. So actually, I'm going to switch over here and show you guys some stuff. So if we go down here, I should have Server Manager open. Right, so here you can see that I've got a 500 gig disk, and I want to right click. I'm going to go New Simple Volume. Next. Let me make this a little bigger for you. All right, next, next, next. You have to change in the drop down here to ReFS, and then the default cluster size is 64K, right? You can either do this manually through Disk Manager, or you could use PowerShell to format this volume for you too. The other important thing that you should know is you can actually use the fsutil command here. So if we bring this up, scroll up a little bit. So if you're familiar with fsutil, you can run fsutil, fsinfo, this command right here, refsinfo against your volume. So this is against my E drive, right? Now this is an RTM version of Windows Server 2016. Let me see if I can move it over a little bit. But with this, It'll actually show you here the ReFS version. So I'm running ReFS 3.1, right? You can check inside of your environment if this is something that you've got deployed very easily. Or you can actually do a comparison. And this is pretty cool. I learned about this after we started to do more with these individual file system. So if you do fsutil volume info, it'll actually give you a list of all the different APIs that are available for that file system. So the one here that we at Veeam are going to take care of and leverage is this block clone, okay? But you'll notice if I run this same exact command against my NTFS volume, there is no block clone API, right? And if I scroll up here just a wee bit for you, you'll see that it is in fact an NTFS volume, whereas the other one was not. It was my ReFS. But you can also, I forgot to point this out for you, you can check your cluster size, right? So this one here, my E drive is formatted with the 64K cluster size. It would be 4096 if it was 4K cluster size, right? 4K times 4 times 1024. So you can see here that that is, in fact, the way that we're configured. So that block clone API is, in fact, the way that Microsoft themselves inside of Hyper-V 2016 are taking care of their checkpoints, which I think is pretty cool. I already showed you the demo. Instant fixed disk creation. Now, this isn't something that we at Veeam are taking advantage of, but if you've ever tried to deploy, anyone ever had a DBA come to them and say, hey, I need a new SQL Server, right? You virtualize SQL Server probably. I know I did. Maybe not the clusters, but if I had individual instances or part of a DAG, right? I'm virtualizing those. I need to create a data drive, tempdb, logs, backup directory. But the recommendation to do that is to make it a thick provisioned or like an eager zero, right? So in a VMware world, I need to eager zero that out. Basically write zeros across that entire 2 terabytes. That can take a long time. Hyper-V 2016 on ReFS, it's instantaneous via this cool thing that they have called instant fixed disk creation. And that's something, if you talk to the program guys at Microsoft, they're very proud of that. So how do I deploy ReFS? The file system itself, as I mentioned, is in 2012, 2012 R2, and 2016. The stuff I'm going to show you with Veeam is only capable inside of Windows Server 2016 and ReFS 3.1, right? Because that's where the block clone API is, and that's what we're going to get to here in a minute. Previous versions, unfortunately, there's no way to upgrade from older versions of ReFS to the latest. It's only in Windows Server 2016, and you got to reformat to get there. So what we see a lot of customers and our partners recommending to folks is to kind of play the shell game. So bring up a new server or bring up a new volume on that server, copy the data off, reformat, copy the data back. So kind of play the rob Peter to pay Paul type approach. And then, as I mentioned, no native way to in-place upgrade. And then actually, one of the things that we recommend to folks is, if you want to test out Hyper-V, put it on your laptop, right? SSD, it's really easy. It can run in the background. But ReFS is actually not on Windows 10 at all, which I thought was pretty interesting. So an important factor is what does it cost? It actually doesn't cost anything because it's natively included inside of the operating system, all the way from Hyper-V Free Edition to Standard and Data Center. So if you've got Windows Server, this is something that you're able to take advantage of today. And inside of the Veeam world, all you need to do is have backup and replication version 9.5 and your repository on Windows Server 2016 with ReFS. So if you're looking at deploying backup storage, now this list of capabilities or issues you should look at isn't necessarily only for backup storage, right? It can be for an application, it can be for networking storage that I'm looking for, networking infrastructure, compute. Scalability, extremely important. How fast can I add additional storage? How fast can I add additional compute nodes, right? Scalability. integrity, right? Reliability. These are all technical factors that you as IT pros should be looking at. The two that I skipped over there are performance and cost, right? Because they're inverse of each other, right? If you want, or actually they're equivalent to each other. If I want high performance, I'm going to have high cost. So, I have an app guy that comes to me and says, or a director and says, hey man, we need to be able to restore all this stuff as quick as possible. And what's as quick as possible mean? He's like, well, we need to be able to get everything back within, or this application back within 15 minutes. We need to have real-time replication from one site to another site, right? Those are common things. Well, guess what? I need to have 2 times the infrastructure, right? I need to have SSD backup storage. I need to have 10 gig infrastructure. I need to have low latency between my sites. There's cost associated with all that. So just understanding that, finding a balance between performance and cost to meet your individual needs is something that you should look at and take into consideration. So if you're going and having these discussions with your director or your CIO or whomever you chat with about making these types of purchasing decisions, that's what you want to look at. So inside of, I got 5 minutes left?
As much time as you want. It's a break after this.
Oh, there's a break after this. Okay. So inside of Backup and Replication 9.5 and Windows Server 2016, the thing that we're going to take advantage of is fast cloning and spaceless full backup in data integrity streams by using that block clone API. So you said you use Veeam in the front here, right? Have you ever tried to do a synthetic backup, synthetic full backup, where it actually doesn't go out and snapshot the environment, right? A synthetic backup is very I/O intensive on my backup storage device. Well, with Windows Server 2016 and ReFS, we're going to leverage that block clone API to reference the existing blocks of data that are already on my repository. So whenever we're building a synthetic backup, or whenever we're doing grandfather, father, son retention, or a reverse incremental backup, we're going to leverage block clone API. So it's going to be instantaneous, because we're just referencing blocks of data that are already on disk. And since we're referencing existing data on disk, it's not going to use any additional capacity. And you'll see that here in a second. Yeah, so it's going to be a lot faster, accelerated full backup transformations, 20 times faster. And it's a test that I've actually done. I'll show you here in a second. So what does this really look like? On the right-hand side here, I have my NTFS repository, right? Legacy, old style of doing things. I take a full backup on Saturday, very common. This is an active full. Go out, take a snapshot, read data in, write a full backup file, right? Monday, Tuesday, Wednesday, Thursday, Friday comes along. I'm going to take an increment using change block tracking, both in Hyper-V and in VMware environments. We're only going to capture the blocks of data that changed since the previous backup. But you'll notice in my backup repository space, 30%, 40%, 50%, 60%, it's taking up additional space. That is what we would expect to see. Now, come Saturday, I actually want to build a synthetic backup. So we're going to start to read in the previous incremental data and write out a full backup file. So 70%, 80%, all the way up to 90%, where now I've got my full synthetic. So every I/O is 3 I/Os, because I have to read production data, I have to read previous incremental data, and then I'm writing out a backup file, right? It's I/O intensive, and it's capacity intensive, because it actually used space. Now, with ReFS, all we're going to do is reference those blocks that are already on disk using this block clone API. So it is literally going to be instantaneous creation of my synthetic backups, my grandfather, father, son retention, GFS, or if I'm using reverse incremental, right? Those are the two backup types that this will work for, because we are just referencing blocks of data that are already on disk. So, the wow. So if I zoom in here for you and make it really easy to see, synthetic backup creation, 5 hours, 31 minutes. Okay? Now this is around 70 VMs. I want to say it was 2.5 terabytes worth of space, right? 2.5 terabytes So it's a decent size data. You can see my performance all over the place, right? The most disappointing part is it fails because my repository ran out of space. And that sucks for me because it was at 94%. And I was like, oh, damn, 5 hours and 31 minutes, and it failed at 94%. Sugar. So if we actually go forward here, and what does this look like on an ReFS? The only thing that I changed is I added another volume to this repository server that is formatted with ReFS. That is the only thing that I changed. Same amount of source data, right? That's 2.2 terabytes. That other one was 2.6. Maybe another VM failed for whatever reason. It's a lab. But that 5 hours and 31 minutes, 29 minutes, right? Look at the performance. There's no, the I/O that is going across my storage array, my backup repository, is literally 0. It's flatlined because, like I said, we're only referencing blocks of data on disk. And the only reason why this took 29 minutes is because we have to update metadata. There's still a VBM file behind the scenes, which is a Veeam backup metadata that we have to update with the retention policy and all that type of stuff. That's the only reason why it took 29 minutes. So you can see in the logs, this bracket, fast merge bracket here in the center, that's how you know that we're leveraging the block clone API behind the scenes. So whenever you, if we switch over here to my backup console, and I switch over here, come on, there we go, right? This is what it looks like. So you'll see here in the job window, it says synthetic full. That's how you know that it was a synthetic backup. This individual job, I only have one VM in it, and literally the retention is like 2, and I'm creating a synthetic backup like every other day, just to be able to easily show this off for you. And then you can see down here, fast clone, and oops, I accidentally hit the Windows key. Oh, geez. We don't want to add my Microsoft account. Just move that aside. For this one VM, it took 11 seconds, right? Is that a good sampling? Maybe, maybe not, but this is what it would look like actually inside of the user interface. So whenever you're adding in your backup repository, you just go under backup infrastructure here, and you can see here that nothing's really changed. All you do is you add the server just like you would any other repository. Will automatically detect that it's the resilient file system, ReFS, enable data integrity streams. Very, very easily for you there, guys, there. So if you're interested in learning anything more, so we covered a lot here. There's a lot more material online. So if you go out to YouTube and just do a search there for ReFS integration, Anton Gostev, who's the Vice President of Product Management, did an Ask Us Anything live YouTube session a few months or so back. Some of the stuff I covered in here is in there, and there's a lot more as well that didn't really think was relevant for this conversation. And actually today, this afternoon, we did a Veeam Live episode about how working with scale-out backup repositories and ReFS, so you can look for that. And then lastly, we've got a lot of free stuff at veeam.com. So if you head on over there, and if you've heard of it, we have a conference. It's called Veeam On. It's in New Orleans this year. And I have a special code I'll share with you guys after we're done recording here. So if that's something that you were interested in going to, you guys get a special registration code where you get a discount, deeper discount. I think we're just about out of time. But with that, if anybody has any questions, I will answer those now. Or if you wanted to, I can hang around for a few minutes too. But I thank you so much for coming out today. We really appreciate it. We good?